Hello, this is the Week 14 Artifact Review for Group 11. So here we have an overview of our system once more and the tasks that we have to complete for Ag Junction system. Next we'll be moving on to the JIRA board, and here are our current tasks in the backlog. So what we've done this week, first of all, is looking at the research of the UART and RS-232 interfaces. We've posted the documentation for these reviews on the JIRA board underneath their respective tasks. So our UART overview is right here, and it contains information on RS-32 and UART interfaces. What we will be working with is the UART interface, which will take parallel data, and the UARTs will communicate between each other in the form of serial data. So data will be getting transmitted one bit at a time before it converts back to parallel data towards receiving device. So moving back to the JIRA board, we have the documentation for the UART and RS-232 posted, as well as documentation for the research of machine learning, which we will be using for this system. Moving back to the presentation, we've done some research on the machine learning and to see how we can implement a machine learning algorithm in C and C++. So there exist libraries for C++ machine learning algorithms, which we will be using to develop this algorithm for Ag Junction. One common one that's open source and available is MLPack, which we can install on a Linux machine with the following dependencies, and it could just be installed from the terminal line in Linux. To give an overview of how this MLPack will work, what we have here on the right is the log files that are being stored on the Linux system. So here's our basic C program writing to the files. So this would write a log file to the Linux system that we have here. Now our machine learning algorithm using MLPack, can come up with these algorithms, and these algorithms right here were taken from the MLPack website. So with this library, we have to continue to develop this machine learning algorithm, and using what is available here, the next step is going to be how can we develop this algorithm to pull from these log files, and using some of these formulas, how can we get the proper data back to Ag Junction.
This is Group 11, Proposal 7 video for our Artifact Review 2. In our Weebots, we are continuing to look at how to manipulate our tractors and also generate the environment for testing our learning algorithm that we are developing. One of the things our sponsors has asked us to do is to create a wide variation of terrains for which our tractors will be able to move on in order to detect different types of terrain anomalies. So we've been working on creating different types of terrain. In this example, we have created 4. So there is this one, which is not as intensely undulated. It's a little more smoother with just like a small bump. And then as you can see on this one, it's a little more varied with how it has a very steep bump at one section. And then on this one, we have a very uneven terrain that is like very kind of like these tiny little rolling hills to really get an idea of how our learning algorithm can react to this environment, and also see how our tractor moves on it. In the last terrain, we have one that's more of like a large hill space for a lot of like uphill and downward hill movement, nothing that's so jagged and rigid, to have yet another example of our different types of terrain we're working with. We're continuing to expand our knowledge about Weebots and how it works, and things are coming along well. And we are beginning to figure out how to have the tractors controlled manually through GPS input.